Bedroom lighting could be made much more meaningful and focused on improving our health. I'm aiming to create a lighting environment focused on tracking my circadian rhythms. But what are circadian rhythms? These are 24-hour cycles in our body highly influenced by light exposure. These have always been dictated by the sun, but artificial lighting has had a negative effect of putting us out of sync. I'm hoping to collect data to see what mine is like, and create actuations to improve my lighting environment and health using sun color synced bulbs, sunset synced blinds, and a web app to understand the data. I'm tracking the indoor bedroom environment with a Pi 3 using a BH1745 color luminance sensor to track lux light levels and RGB colors, which I then convert to color temperature using the Python color science module. A DHD22 tracks temperature and humidity, all parameters relevant to sleep patterns and lighting. I approximate the outdoor ideal color temperature by using the Astro module to get local sunset and sunrise times, and Pi Solar API for solar elevation at these times. Then I create minimum maximum boundaries for color temperature, 6000 Kelvin at midday and 0 Kelvin at night. Solar elevation is then tracked throughout the day, and this creates a sinusoidal type plot that phase shifts slightly every day due to changing sunrise and sunset times. Finally, my sleep state was tracked using a Fitbit. This collects overnight, aggregates data, then syncs with my phone when it is next on, uploading data to the Fitbit servers. I collect this using a GET request and create an implicit GrantFlow authorization token to enable access. I use a cron job scheduler to collect the data at the end of each night to make sure I don't miss any sleep data. This is all automatically uploaded to ThingSpeak every minute, and the Fitbit data is uploaded at the end of the day with a bulk upload using a post request. The data was collected and put into visualization tools on a website. You can see what my sleep state is and the lighting conditions in my room versus the ideal outdoor ones by hovering over the graphs. You can see that usually when it's dark outside, I'm awake. You can also see raw data plots and correlation tools, and there's a live feed on the final page. The code is built using Dash-Plotly using a Flask framework. Callback functions are used to enable interaction, and styling is achieved using CSS. Data plots show that my sleep cycle is very poor, with my sleep having a negative correlation with the natural cycle of the sun. Ideally this should be 1, but mine is minus 0.3. So I made actuations to help me improve this. My bulbs are synchronized to the outside color temperature function I made before, meaning when it's midday they're set to 6000 Kelvin, but towards the night become warmer. The unique part is that this syncs with the sunrise and sunset times, whether it's summer or winter, unlike existing solutions which are just static times. I interact with the bulbs over LAN, meaning it's highly secure using the Tiny Tuya API. I send JSON requests with a Python script scheduled to run every 20 minutes so that the light change is not constant and distracting. The code for this is similar to the bulbs, but instead of changing color, they open during daytime and close during night. Once elevation is beyond a certain threshold value, it sends a hardware time PWM request to the servo. To add greater user control, I also made the blinds Alexa controlled. Alexa, ask my project to open the blinds.
Sensing an IoT is super epic.
Alexa, ask my project to close the blinds.
Sensing an IoT is super epic.
I do this by hosting a Flask server on a Pi 4. Using the Alexa developer console, I made a voice interaction model that triggers a skill and sends a request to an endpoint which goes to the Pi. The interaction model is captured as a JSON file. The endpoint was created using local tunnel, which directs the request to the Flask server. The second part of future lighting is emotional lighting. RGB bulbs are advertised as mood lights, but that's after I tell them what mood I'd like to be in. What if my light could tell me what mood I'm currently in? To track my emotions, I used OpenCV and my PC webcam to get the highest frame rate. The code works by using a Cascade classifier to draw a box around my face, then it crops this and scales it to 48 by 48 pixels and grayscales it to match the format that the model was trained on. I used a pre-trained model with a dataset of 27,000 faces. This helped me save time on training and found it works pretty well. But I wanted to train a personalized model to see if it could pick up subtleties in my expression. I got 190 pictures from my camera roll and manually labeled them. I used the same code format as the OpenCV script, but passed a folder of images instead of webcam frames, then outputted lots of tiny pictures of me. I put it through a 7-layer convolutional neural network. It had 55% accuracy and could better detect subtleties, but only for happy and neutral. This is because my dataset had the most images for these emotions, probably because I don't take many pictures while sad, angry, or surprised. I collected the emotion data during an 11-hour work session and averaged the data into a window size of 30 readings to save on file space. These were saved into a CSV file. This was automatically uploaded to Google Sheets using GSpread API. The data can also be visualized on my website too, with an interactive rolling filter to view raw data or a custom filter window. Finally, I make my lighting truly emotional by using the LifeX API to change color based on a new prediction in real time. Here's a reel showing it in action. Please check out my project on GitHub and my website on bedroomlightingfuture.herokuapp.com.